teachers, fellow grade 12s, and I hope everything went well with paper 1 this morning. I am Mr. Nambani, the subject advisor for physical sciences in the Motheo district, and my key responsibility for the day is very simple and very easy. It's basically to share tips and tricks of how to approach technical sciences paper 2. So without wasting any time, let's quickly get into it. And the way I want to start is for us now to look into the actual layout of the exam. What is it that we need to expect? What will be the format of the exam thereof? So we have two critical topics that we need to focus on. The first one is matter and materials, which will be 47 marks, and chemical change now, which will be 28 marks. So this now sums up to a total of 75 marks. So it basically says we only have now 1.5 hours to complete this exam. So it brings me to a point where, in a situation where you have this time that is given, it is critical to basically time yourself such that you can be able now to complete the exam in the given time. So with the exam layout, we expect to have question 1, which will be multiple choice. So with multiple choice, we'll be given your 4 options, and we need now to choose a correct answer. But I will get into the critical ways of how to approach the multiple choice once we get into the individual questions. And now we also have organic chemistry, which will be plus or minus 40 marks. So when it is plus minus 40 marks, it basically says it is important now for us to actually look into it, because it has now a higher marks, or the marks allocated to the organic chemistry basically contributes almost half of the paper. So when we sit down over this weekend trying to prepare, maybe our key critical focus should be on the organic chemistry. So in organic chemistry, we have your nomenclature, which is naming and structures, physical and chemical properties, and also organic reactions. So further in my presentation, I will get deeper on how to approach nomenclature, how to approach physical and chemical properties, as well as now the organic reactions. And then we have electronic properties of matter. That will also be plus minus 7 marks also, usually around 4 or 5, but the maximum will be 7 marks. We'll also get into that when we do individual topics. And then the other one now, it's electrochemistry, of which, because it is done in term 3, a majority of us as learners, a majority of us as teachers, we don't necessarily teach it the way or the best possible way we can, because now this one, we have our galvanic cell, and we also have our electrolytic cell. So for the purpose of emphasis, I decided now to break everything into small parts to actually be in a position of explaining each and every key critical concept when we get into the electrochemistry. So basically, these are key critical topics that one needs to focus into. For one to pass, the critical one will be us now looking into the organic chemistry as well as the electrochemistry. So once that is done, majority of the work have been attended to, and the majority of the assessment will come from that. So that is the reason why, if it happens because of the time constraints, I do not get to electronic properties of matter. It's only because of the key idea is to attend to the topics that has or contribute a majority of marks. So without wasting any time, let's get straight into the multiple choice. So when we work with multiple choice, the tip will be read the question at least 2 times. Why need to read the question 2 times. It's basically now to identify the key critical words that will be in that particular statement. So this is important now for us to identify critical words which obviously will influence our choice of the answer that we are going to choose. So reading it twice is basically to identify critical words, because we end up now being lost in terms of the wording that now the examiners use when trying to explain different concepts or assess different concepts when coming to multiple choice. So preferably read it twice, such that now you look for these critical words. One of the key things is they always now capitalize letters or words. Now, when we have capital letters, it basically says it's now another critical word that the examiner is giving to us that we can use as a form of a tool in order to choose the correct answer. Then immediately thereafter, there's a process of elimination that we need now to apply, of which I am going to try and explain in simple terms. You will always be given 2 distractors. What do we mean by 2 distractors? By 2 distractors, we mean answers that don't have anything to do with that particular question. So these are just the distractors, and they are usually 2 distractors that are given. So these are answers that don't necessarily relate to the question. So it is always now important for one to realize that. So thereafter, once I have eliminated the distractors, I must use either principles of physics to reason and now choose the 2 options that are remaining. But now to write the correct one, this principle of physics, this understanding of the concept is the one that is going to assist me in terms of choosing the correct answer. So physics principle can also relate now to a specific topic, can relate now to a physics principle, can also relate now to a definition or even a statement that we normally use, or anything that can be in a position of assisting us to ensure that we get to the correct answer. Then the last part will be now write the correct answer next to the corresponding number. And the correct answer, remember, it must be a letter. You do not have now to rewrite the sentence or rewrite the words that are given. So this is an easier way of one saying, if I have a multiple choice, let me read it twice, check now or identify the critical words within the statement that will assist me to fully understand or know what is it that the examiner is trying to assess. There will always be 2 distractors, of which they do not have anything to do with that particular question. So I've chosen a question here that says the energy conversion that takes place in a galvanic cell is from. So the best way of me going to do this is to try and identify my 2 distractors. So it is easy to see that when we work with a galvanic cell, we definitely know it does not have anything to do with the kinetic energy. So it basically says C and D are my 2 distractors. So now I am left with what? I am left with A and B, which will be now what? Which will need me to have a physics principle, which will either have a definition, which will either relate now to the topic in order for me to choose now the correct one. So now knowing a galvanic cell is the energy change or the conversion of energy is from now chemical to electrical energy. So this I can only know if I know exactly what is the use of a galvanic cell, how to define a galvanic cell, the energy conversion in a galvanic cell, which brings me now to a point where we say immediately after eliminating the distractors, it is key, it is important for one to apply a certain form of a physics principle. So the physics principle allows us to choose now and eliminate the other option, which gives us immediately the correct answer. So this one becomes easy because we decided now to eliminate two distractors. Immediately thereafter, apply the physics principle of exactly what is a galvanic cell. Then immediately we are able to eliminate the one that is incorrect, and this allows us to be almost closer to getting the correct answer right. So another tip of which I did not add here, when it gets complicated in multiple choice, please write anything in multiple choice. This is the only section where you are allowed now to at least guess or write something. Because now when you leave a space, unfortunately, there isn't any mark. Even if we decide now that maybe the question was vague or ambiguous, we award 2 marks, we only award 2 marks, provided that you tried now to attempt the question. So this is the question where if things get a little bit tough, kindly just write any of the letters such that you are in a position of being awarded a mark at some stage. So this is now basically the critical tips that I feel that when we attend to multiple choice, which will be question 1, then these are ways of how to go about it. With the organic chemistry, I tried to compile few bullets that majority of us are doing as learners, the common errors and the misconceptions, and the errors that now contributes to us not getting the maximum marks. Key critical thing is candidates confuse definitions and omit keywords in the definition. So what does this say to me? It says it is important for one to know the definitions. There isn't any much thing to do with definitions. It's just now do not omit any key critical words, because this is now either 2 or 0 in most cases. So if it is 2 or 0, what does this say to me? You omit a keyword, you don't get a mark. So it is key critical to say, let's use now our terms and definitions that were provided by the department in order for us to give our definitions. Let's not omit any keywords. Hence here, as a corrective measure, it will say here, kindly now learn the definitions from the exam guideline, but for us, we also have terms and definitions. So it is very, very critical for one to use the terms and definitions to provide now the correct definitions. Remember, definitions will always be there and they will contribute a huge chunk of the marks. So it is important that we provide now the correct definitions without omitting any critical keywords. Now let's look at bullet number 2. It says, when writing an IUPAC name, candidates omit hyphens, commas, and numbers. So I am going to use A as an example. So when I use A as an example for me to give now the IUPAC name of A, I have it here with me as 4-ethyl, 5-methyl, hept 2I. So this is quite a huge name for one to get it right. You need to have a system, you have to have a way of approaching it. So this is the IUPAC name for A. Now check this. Between every number and a name, there is a hyphen. Between a number and a name, there is also a hyphen. Between the stem and the functional group, there is also a number. So it basically says we do not need to omit any form of a hyphen. Numbers needs to be correct. And remember, we must now arrange everything in an alphabetical order. So arrange in alphabetical order. That is now very, very important for one to remember, because once we do not do this, it basically says we are going to lose a couple of marks, because for such a name, a learner or yourself can be able to get a maximum of 3 marks, because usually we will say if the parent name is correct, we'll give you 1 mark. If you have correctly identified the substituents, we'll give you 1 mark. And the other one is maybe the whole name is correct, then we can be in a position of giving you a maximum of 3 marks. But what is critical here is how to go about ensuring that you have now the correct IUPAC name. So remember, do not omit hyphens, use your commas if you have more than one type of substituent, and at the same time be able to differentiate in terms of the different functional groups you have, because we usually say the suffix of the parent name usually tells us about the functional group, usually also tells us about the type of the homologous series that we are working with. So if you do not know that, everything now becomes a challenge. One critical thing is we usually draw now an incorrect structural formula. The reason for incorrect structural formula is now for us not knowing exactly which homologous series, which functional group should I be drawing for. What does this say to me? It says now, I will always be given an organic molecule. But now from the organic molecule, I need to know the homologous series to which it belongs. That is now very, very critical. From the homologous series, I should also be in a position of knowing the functional group, either by name, either by the structural formula, but it is critical for me to know everything that has to do with the organic molecule in terms of the functional group and the homologous series. I will quickly now go to show you that once we have done all these 7 pillars of organic molecules, everything becomes easy, because we are feeding now the information into this specific organic molecule. Immediately thereafter, the IUPAC name is what we also need to know. We can further move and say there must be a general formula, and we also need to have the structural formula. But from the structural formula, I can further move and say, do I need now to know anything about the isomers? Definitely I need now to know something. So what does this say to me? It says I can have my chain, I can have my position, and I can also have my functional group. So all the questions related now to naming and structures will follow these seven pillars. So this says immediately I can have my position isomer, and lastly I can have my functional isomer. So this is a structure that I feel and believe that the examiners are going to use. This is a structure that I feel if we know everything that has to do with a specific organic molecule, then we are in a good position of getting everything right. Let's look at D as an example. I am at compound D as an example, where we are given the name of that particular structure, which is now what? The IUPAC name. So if I am given the IUPAC name, which is here, what are the possible questions that the examiner can ask? The examiner can ask to which homologous series does compound D belong to. The examiner can ask, draw the functional group of compound D. The examiner can ask now, give the general formula of compound D. The examiner can also ask, draw now a structural formula of compound D. So what does this say? This says to me, if I am working with an IUPAC name, the possible questions should come outside this IUPAC name. So if I am given a structure, let me quickly remove this and say now, what if I am given a structure? If I am given a structure, for instance, let's look at B for the purpose of this explanation. I am given a structure. What are the possible questions that can come from being given a structure in this specific table? The examiner can ask, give the IUPAC name of compound B, to which homologous series does compound B belong to, draw the functional group or give the name of the functional group of B, write the general formula. But because now when we check there, it is a ketone, does it have an isomer? Definitely it does. So the examiner can also ask now to give the functional isomer of compound B. So what does this say to me? This says to me, whenever I am working with an organic molecule, the key critical thing is to ensure that all these pillars, as I call them, are being attended to. 1, homologous series. 2, functional group. 3, your general formula. 4, it's your structural formula. 5, now is your isomers. And 6, it's the IUPAC names. So for homologous series, I usually extend it further to say the possibilities of asking whether it is saturated or unsaturated. It's what examiners can also ask. So it is always now important and critical to say, when we sit over the weekend to try and follow up on organic chemistry, especially naming of structures, it is critical to ensure that we close now all these 6 key bullets to ensure that everything we have done and we are prepared now to go into that specific examination. So this is very, very important. We should not try not to know our general formulas. But because I did mention earlier on that the Department of Education developed a nice now terms and definitions for us, so I will kindly now refer you to terms and definitions as a booklet that now each and every learner who's doing technical science in the Free State should have. So I want you now to go to page 2. I want you now to go to page 2, and for page 2, this is now where you can find everything nicely summarized with the name of the functional group, with the homologous series, together with the general formulas, as well as how to go about writing the correct IUPAC name. So basically, this is a few of the critical things that we need to know, because basically those are the questions that examiners ask, and I can put my head on the blog and say the routine of how to ask questions is not going to change anytime soon, because the content is the same. And what is important is when you have addressed each and every segment or each and every bullet that I indicated here, then definitely feel free to go into an exam knowing that you will be expected to write an IUPAC name, you will be expected to give the general formula and the other ones that I did explain. So with that being said, it brings us now to the end of naming and structures. So let's quickly go to physical and chemical properties. So critical mistake that we usually do, or the common mistake, remember, definitions are very, very important. So it says here, candidate confuse now definitions and omit keywords. But when we come here, what are the critical keywords or definitions that one needs to look for? One word that we need to look for, or a couple of words, I will say 3. It will be now our melting point, boiling point, and vapor pressure. So these are the critical keywords or definitions that the examiners usually ask that relate to physical and chemical properties. So the procedure is still the same, the advice is still the same, that learn your definitions from the exam guideline. But now, when coming to long questions, we need now to compare. It says candidates could not interpret the table to explain the trend in boiling point, melting point, and vapor pressure. So the key thing here is we fail now to interpret the tables that are given. We fail to understand exactly what is it that the examiner is assessing. We fail to understand how to go about now answering this particular section of physical and chemical properties. But what does it say? I tried now to develop an easier way of how to go about identifying which factor is actually influencing the change in boiling point, the change in melting point, as well as the change in vapor pressure. So I am going to quickly explain a few. We have 3 critical factors. 1 is number of branches, 2 is chain length, and the 3rd one is your functional group. What does this say to me? This says to me, if I am going to compare branches, then the compounds that I am comparing must belong to the same homologous series. If I am going to compare chain length, they must also belong to the same homologous series. If I am working with alkanes, it must be alkanes throughout. If I am working with a carboxylic acid, it must be carboxylic acids throughout. But now they must belong to the same homologous series. That is very, very critical. But this does not assist in terms of, is it the number of branches or is it the chain length? Then it basically says we need something extra to solidify our choice of which factor is influencing the boiling point and the melting point. So for me to use or to explain in terms of the number of branches, then it basically says the compounds that I am comparing must be isomers of each other. What are isomers? Compound with the same molecular formula but different structural formula. So I am quickly going to bring this one forth for the purpose of explanation. Let me quickly increase the size for purpose of explanation to say fine. When I look at A, it is 2,2-dimethyl propane, and B is 2-methyl butane, and C it's pentane. And the examiner is now telling me that these are isomers of each other. So the fact that they are isomers of each other, it basically says it must be isomers, and they are isomers, so it means the examiner is asking me to explain something in terms of the number of branches. Once I have identified the factor that the examiner is assessing. It basically says I will be in a position to answer correctly. I will be in a position to associate the different boiling points with now what? The strength of the intermolecular forces. So the emphasis is look for what the examiner is asking for. Look for what is the factor that the examiner is asking for. Now let's quickly bring this one forth also. This one will explain now the chain length. When I look at A, it's shorter, B it's longer, and the longest here it's C. So it basically says we are now increasing the number of carbons, and once increasing the number of carbons, it basically says we are going to have a different in molecular mass. So once I have different molecular mass, it basically says the examiner is asking for chain length. So once I have identified which factor is the examiner asking, it is easy for me to give proper reasons why do we have differences in chain length, differences in boiling point, differences in melting point, as well as differences in the vapor pressure. So now, with this being said, it says to me, what about the functional group? Obviously, for functional group, compounds belong to the different functional group. Compounds have different homologous series. So this is where now I am comparing an alkane with a carboxylic acid. So this one now is very clear that the two belong to different functional groups. And the fact that they belong to the different functional groups, it basically says I need now to compare what? The type of intermolecular forces. Compare the type of intermolecular forces, and focusing more on the strength of intermolecular forces. So I will say now compound A has, which is an alkane, has London forces. Compound B, which is a carboxylic acid, has now London dipole, but the most strongest one in this instance will be a hydrogen bond. So because of that, I need now to compare the strength of intermolecular forces and conclude also to say carboxylic acids are stronger than alkanes. So it basically says once I am comparing in terms of functional group, compare the type of intermolecular forces and also conclude in terms of the relative strengths thereof. So when working with functional group, it becomes somehow a little bit easy, but we need now to know the type of intermolecular forces. So the types of intermolecular forces are given now in our terms and definitions, and this is on page 9. So please, when you are trying to prepare, know exactly which homologous series has a specific type of intermolecular forces. Also know in terms of the strength of the intermolecular forces. This is because a question will come where you need now to compare different compounds that have or belong to different homologous series. So let me quickly go back to explain now one last bullet. For me to explain that one last bullet, it is key to say if I am working with number of branches, the compounds belong to the same homologous series and they are isomers of each other, and most importantly, they have the same molecular mass. But what is key and general here is that increase in number of branches decrease the surface area. That is what the examiners want to hear. And because of that, and remember, because they belong to the same homologous series, they should have the same type of intermolecular forces. So we only compare in terms now of the strength of the molecules that we are referring to. So a decrease in surface area results now in a decrease in strength of intermolecular forces. Therefore, this is the bullet that I want to add. Last bullet is always more or less energy is needed to overcome the intermolecular forces of compound that we are referring to. So it becomes now an easy way of us looking into it in the purpose of giving the examiner exactly what we need in terms of allocation of marks. So that is very, very critical to now, after concluding in terms of the strength of the intermolecular forces, it is critical also to include the amount of energy, either more or less, that is needed to overcome, critical weight, not to break, but to overcome the intermolecular forces of compound that we are referring to. So this is now a nice brief summary, a clean sheet that I feel that when we go into an exam with this strategy, definitely one should be able to get a certain amount of marks and be in a position to perform well. So that is now basically it about physical and chemical properties. I hope I tried now to explain in detail for you to understand what is it that you need to look for once you get into that examination. The last one here under organic chemistry is organic reactions, and organic reactions are also very, very important. So with organic reactions, for us in technical science, we only look for addition and substitution. There's a diagram that I have here that explains all these nice ways of looking into the diagram. But before getting directly into the diagram, there's an analogy that has always worked for me to remember everything. And this is a simple story of, at some stage I was single and seriously searching, and I went to the United States of America. But how does now this relate to the science? It says now basically, if I am working from saturated to saturated, that reaction must be substitution. When and how can one identify whether a molecule or an organic molecule is saturated or unsaturated? It goes back now to this specific slide here, where I said when we work with organic molecule and we are looking at a homologous series, we need now to further extend it in terms of saturated and unsaturated. So it basically says it is a build-up from naming and structures. So it becomes easy once that part of naming of structures is done and everything is correct. It becomes easy to know what is it that we mean when we talk of saturated. What is it that when I say I am looking for unsaturated, from unsaturated to saturated, that reaction should be addition. So when I do this, it is for the purpose of saying when I move from unsaturated to saturated, this reaction must be addition. So this is a nice analogy that I want us to try and use in order to identify the type of reactions that we have. Because with that, everything now sits well. The question comes when we have to explain different types of additions that we have. But the mere fact that we are on the right track of knowing that we are working with addition, it basically makes it easy for us now to choose exactly which one is going to be more relevant according to the information that is given. So I'm going to try and apply this analogy to the diagram above. Let me start here to say when I look at an alkane, it is saturated, and moving to a haloalkane, it is also saturated. That is the reason why we will be in a position to say definitely that reaction must be a substitution reaction. When I look at an alcohol in this instance, when I look into an alcohol moving into a haloalkane, it is saturated, moving to saturated, so definitely this reaction should be a substitution reaction. So once that is done, everything definitely becomes easy for me to identify. So I am not given any form of an organic molecule to draw structures, to do anything like that, but the key critical thing is I am able to identify the type of a reaction. Let me check if I can be in a position to use now the USA. For me, using an USA, I must start from unsaturated, which is now my double bond, which is unsaturated. And if I'm moving from unsaturated to saturated, looking at the haloalkane, that reaction must be addition. If I am moving from unsaturated to saturated, that reaction must be addition. If I'm moving from unsaturated to an alkane, that reaction must also be addition. The fact that now I know it is addition may be the only thing that I need to worry about. It's the type of addition that the reaction is. Is it hydrohalogenation? Is it halogenation? It automatically now depends on what is it that we have and the type of information that the examiner is giving. So this is an analogy that I want us to go and take and use now in our exam, such that we do not forget, such that we are in a position of basically getting everything right. So with addition comes now reaction conditions. We should not omit reaction conditions. So reaction conditions are very, very, very important. So reaction conditions are basically a guideline of what to look for, are basically a guideline of things that the examiner will give as hints in terms of how to or what type of addition it is. But before the reaction conditions, definitely the examiner will tell us something about the saturation of this element. Is it saturated? Is it not? Is it unsaturated? Then from that we can easily know that that reaction is going to be addition. The possible question will be, give the reaction conditions. So I want now to refer you to our terms and definitions, where now we look into page 11, which is very, very important, that it will give you now all the possible reaction conditions. Because if I will want to go into each one of them, then I will not be able to complete the presentation, and I will not now be sharing all the nice critical ideas of how to go with this paper too. So this was a sketch from a typical exam paper. I am quickly just going to apply the analogy of our single and seriously searching, and I went now to the United States of America. So I am going to start here with propan 2-ol. It is an alcohol, it is saturated. Moving now to 2-bromopropane, it is saturated. Definitely then B must be a substitution reaction. Now the question should be, what type of substitution? That will follow, but the key critical thing is I have used the analogy to identify B as now what? As a substitution reaction. Now moving from propene, is it unsaturated or saturated? Definitely unsaturated. And because it is moving from unsaturated to saturated, then this reaction C, it is now an addition reaction. Moving from propene to propane, that reaction D is also another addition. And if I am moving from propene to propan 2-ol, it's another addition reaction. But the only thing that I need now to worry about is what type of addition it is. So I am not going to be hunting out addition and substitution. I will confidently say this is addition. The only thing that now I need to worry about is what type of addition. Furthermore, we still have our combustion reaction, and this combustion is for alkanes. So where we have an alkane that now reacts with excess oxygen, the products will always be carbon dioxide and H2O. Look for that also and be able now to label everything thereafter. Then we have an ester. This is a reaction now between a carboxylic acid plus an alcohol. So it gives us now an ester. Just know the properties of an ester, just know which one it is an ester, and also we have H2O that is going to be formed. So this is nice summary of the reactions that we need to worry about, but the only critical thing here is the key condition when we are looking at substitution. It's heat, which will be mild heat, but preferably to avoid issues of mild and strong heat, just say heat, and then definitely a mark will be allocated. So that is it with organic chemistry, naming of structures, physical and chemical properties, and your organic reactions. Let's quickly go now to electrochemistry. So when we get to in electrochemistry, this is our galvanic cell. So in a galvanic cell, possible questions is we need to know the direction of electron flow. At the very same time, we need to describe the direction in which ions are flowing. So I chose this diagram because it clearly indicates which ions are going and which side the cations are going. And we have our anode and cathode. I will explain that further. And then write down the half reaction that takes place in each electrode. Write down now the overall cell reaction. I am going to add here to say write down the cell notation. Write down the cell notation. So for the cell notation, it's very, very important also. But this is the cheat sheet that I have. Remember, in an exam, we are given a formula sheet. So the formula sheet is there for us to use. So when I am given the formula sheet, I am going to use the formula sheet in order for me to remember everything that has to do with a galvanic cell. When I look into the formula sheet, I can easily say, once I have identified my oxidation, which is the loss of electrons, everything will build from that. So from the formula sheet, one can easily say, if I have oxidation, it will take place at the anode. And if I have identified oxidation, that substance that it is going to be oxidized, it is going to be a reducing agent. So for me, when I am asked to identify my reducing agent, I can easily come back and now check which one is undergoing oxidation. At the very same time, if I have now my oxidation, I will know it will take place at anode. Then I can easily do the same. I can easily do the same for cathode, where reduction will take place. And if I have identified its reduction, definitely that substance that is now undergoing reduction should be my oxidizing agent. So this is critical because it always becomes a question of one not being able to identify the correct reducing agent and one not being able to identify the correct oxidizing agent. So to avoid the confusion, here is a cheat sheet to say when I look into the equation that is given to me of E naught is equals to E cathode minus E anode, definitely I can use that in order to inform me in terms of the anode oxidation reducing agent, cathode reduction, and now oxidizing agent. And the question here says indicate also the direction of the electron flow. Once I have identified which one will be my reducing agent, then the electrons will be transferred from my reducing agent to my oxidizing agent. But that is important for one to be in a position of identifying oxidation and reduction. Once we have identified that, we have actually answered question number 1, which is now know the direction of the electron flow. Also describe the direction of ions, at the very same time identify anode or cathode. So it basically says everything that we want now to do will be based and focused on us knowing definitely that if I can be able to identify which one is undergoing oxidation, then definitely everything will feed in from the formula thereof. Everything will feed in by knowing the definitions thereof. So the issue of which one is a reducing agent, which one is an oxidizing agent should now fall off, because I need now to start for looking into my formula sheet and the table of half reactions. So write down the half reaction taking place at an electrode, comes back now to identifying the type of reaction taking place there. Is it oxidation? Is it reduction? And immediately write now our overall cell reaction. So for overall cell reaction, just remember we only balance the electrons, and once we balance the electrons, everything becomes okay. Then we can write our overall cell reaction. But now with cell notation, let me write it here. We have now our salt bridge, and everything on this side with phase border will be from our reduction, and the phase border, and everything on this side will be from our oxidation. So what does that basically say? It basically says to me it is important for one to know how to identify oxidation and reduction. Once that it is done, definitely then everything will be easy for us to understand. Maybe one should also add here that also know the standard conditions in which the cell operates. Know the standard conditions in which the cell operates, because those are now possible questions that examiners ask. Those are possible questions that when we get them right, everything now sits well and we are in a position of getting the maximum marks. So this is it basically with a galvanic cell, and try by all means now to use your formula sheet in order to minimize the mistakes. Hence, I am using the formula of E naught is equals to cathode minus E anode in order for me to link everything here. So I am linking the formula with oxidation, reducing agent, and thereof in terms of the electron flow. So the fact that I know it is oxidation, it is a loss of electrons, then the reducing agent will lose the electrons and the oxidizing agent will gain the electrons. So my electrons basically will move from my reducing agent to my oxidizing agent. So this becomes easy for one to follow, and this becomes now a nice summary that one can use. So let me quickly go to an electrolytic cell, because we only have now 5 minutes or so to complete everything. But before the electrolytic cell, these are key critical differences that one must look into. The first one here says electrolytic cell, we need now to have a power source. Very, very critical. And for a galvanic cell, no power source needed. And this is now critical, I must also highlight, to say energy conversion is what basically tells us in which cell are we working with. Are we working with an electrolytic cell? Are we working with a galvanic cell? Because in most cases, the mistakes that we do comes from not knowing which cell are we operating, which cell are we focusing on. So these are critical things. Once you see a DC source, be in the lookout that the chances are you are working with an electrolytic cell. Critical in a sense that when you draw, perhaps if the question wants you to draw, of which I doubt it will be one of the questions, but it is important now, even if you look into the cell, just identify which one is positive, which one is negative, then everything else comes back to this. If you have identified your anode, then you know your oxidation where it's taking place, then you know your reducing agent. So what is critical is to identify which reaction or which electrode is going to undergo oxidation and undergo reduction. And now this is one of the questions they usually ask in multiple choice. The reaction that takes place is non-spontaneous. It is driven by the DC source. So we need now to know what basically it means when they say it is non-spontaneous. We need now to give it the energy in order for us to operate that specific cell. So these are key critical differences, such that you know when you give your answers, you give your answers for a galvanic cell. When you give your answers, you give your answers now for electrolytic cell. With that being said, let's get into two critical processes that you need to know for technical science paper 2, especially looking into electrolysis or electrolytic cell. So for purpose of electrolytic cell, these are the two things that we need to be looking for. These are two processes that we need to be looking for. I went through a couple of papers. Electroplating has not been assessed mostly in tech science, but because the exam guideline and the CAPS document says it's one of the concepts that needs to be attended to, I will be in a position of believing that once we sit down preparing, let's do something that relates now to electroplating. Majority of questions have come to address issues of decomposition of copper chloride, and zinc cell, in most cases copper zinc cell, but that now seems to be overdone. That has been over-assessed. So the examiners need now to come with few different types of questions. So expect to have electroplating. If it's not there, it is a bonus, but if we have prepared for it, then it is also a bonus. If it is in an exam, we will be able now to say something. So it says here, cathode is an object to be plated. So it basically says the object to be plated will be on our cathode. Then it basically says electrolyte are ions or metal of plating. The solution contains ions of the metal which the object will be covered with. So we are going to have now our ions being placed here on top of the metal, such that we can have now a nice coat of a new metal being formed here, or ions being placed on our object. And then it says here at anode, what happens is we have a metal which the object must be plated, anode made from the same metal than that other one of the object will be covered with. So this is just a basic example. This is just a basic way of saying we also need now to look into electroplating. And when you think of it, then this is basically it with paper 2 of technical science. I wish we had more time for us to explain everything, but with this being said, from me to you, thank you very much for giving me your ears, and thank you very much for listening to me. I hope and wish that when Monday comes, you will use a few of the tips that I shared with you. You will also be in a position of preparing well for Monday, because the only thing that we desire is for you to do well in your exams. So I hope the tips and tricks that I shared with you are now with you in order for you to use them. But now, fortunately enough, in this studio that I'm in, we are running a competition of MTN, and you will be now getting a prize from MTN for you only to answer the following question. But now the question should be, how do you enter for this exam a competition, or how to answer the question? Is very easy. You go to Free State Department of Education on Facebook, FS Department of Education on Facebook, and then you just give your answer, and then you will be contacted if you are one of the prize winners. So now on the screen you will see the question, and the question says carboxylic acids have a high boiling point than alkanes. Which type of intermolecular forces is responsible for this difference? So carboxylic acids have a high boiling point than alkanes. Which type of intermolecular force is responsible for this difference? So you write your answer on the Free State Department of Education Facebook page. I believe you are also live there. So when you give in your answer, then definitely you should be contacted when you give the correct answer. Then from me to you, this is now the last slide that I want to share, which basically says your effort is sure to win. Keep up the spirit. We cannot put our heads down now. We need to fight until the last whistle. So for me, Mr. Nambani, thank you very much, and all the best for your coming examinations. Thank you.